So part of one of the question in assignment 5 is also eigenvalue eigenvector problem. Maybe after talking about assignment number 2, if we have time, then we go into this assignment number 5, briefly talk to you about the strategy on how to solve assignment number 5. Okay, so let's start with the assignment number 2 first. Okay, so there's multiple sets. There's multiple sets. Okay, a little bit of statistics. Remember, I told you that for assignment number 2, you have to download it before 4th of April, if I'm not mistaken. Okay, most of you downloaded before 4th of April. And then 2 requesting me to reopen the assignment so that they can download it. And then there's one requesting on a Friday, sorry, not on a Friday, on a Thursday. And I told him to download before midnight. Unfortunately, he did not do anything until the next morning, where he contacted me and asking me to reopen. Asking me if he can call me. I said no. I didn't say anything because Friday and Saturday is my day off. Please, it's my time with my family. It's my time to basically depressurize. So do not disturb during my break lah, my Friday and Saturday. Okay, if you leave a message on a Friday or on a Saturday and on Saturday, but I did not respond, part of it because of it's my day off. So I'll respond the next Sunday morning I will respond. But most of the time I will not respond because I want to just forget about work on a weekend, So I need to enjoy myself. Right, so that's assignment 5, That's assignment 5. So I don't know what happened there. That unfortunately that guy did not submit anything because he missed the deadline to download the paper, even though it's been extended for him, but he didn't do anything. All right, so let's go to this question first. Okay. Hope you can see this is the question. I think this is past year question from test 1. Past year question lah. I don't remember, maybe a year or more ago lah. So I think if you learn solid mechanics, if you take a component design class, this is what we call an open belt system. Anyway, this picture is from Shigley component design textbook. So this is the equation of the length of the belt, which is from here. If you look at the equation, you can see that L is just a total. So half of this one is basically this part and this part. Okay, and this is this part and this part. So that's the formula. And if you look at this, it is dependent. L is dependent on C, which is the center length, the big diameter, and the small diameter. Small diameter of the pulley, which is this, the small pulley is this one, the bigger pulley is this one. Okay, and of course there's an angle here. Angle of rack, or small d and capital D, and this is the speed ratio. So in this problem, it says that if speed ratio 2 is required, basically d over d equal to 2, with L equal 1727 and d equal 150, answer the following question. Okay, the first question is write an equation in terms of all variables involved. So in this case, the variables involved are basically all these three, and of course, this part of all these three is in your theta small d and theta capital D, which make it more complicated. So in this case, it says that in terms of all variables involved, that can be used to determine the value of center distance C. Okay, look at this equation again. Look at this equation again. So you need to identify, the first thing is that we know that L is our explicit, explicit because it is alone on the left-hand side. But what we need to do is, in your normal practice for algebraic problem, what we'll do here is that basically you will try to put c on the left hand side, right? But unfortunately, c square is here, and then we have c as in the function of sine, arc sine, c here. So this is not easy to reorganize the equation in such a way that c will be put on the left hand side. Okay, so this is the issue here. So this is what we call c is the implicit variable. C is an implicit variable. Okay, so do C, D, and small d. Okay, yeah, D here, capital D here, D small here, and then D here, D here. So not easy to do that. So the best way to do is, the simplest way is to just plot. Okay, because we know the other values. For example, if we know D, in this case, we know that this relation means that capital D is just twice the small d. Okay, so we know everything now except for C. So what we need to write is, we need to write an equation, okay, in terms of L, in terms of C, because everything else is known. Okay, so let's do that. So it's my solution here. So let me refer to my solution. Okay, so the equation here is okay. Some of you might get different set. I think I don't need time. I don't think I have time to explain all the versions that we have, but the approach is the same. So in this case, what I'll do here is that we know the equation is L equal to 4c square minus d square half of d theta d plus d theta d. Okay, and we know that theta small d is something else, capital D is something else. And given that we know that d over small d equal to 2, L equal to 1727, and d equal to 50. So what we need to do is to write an equation FC, and in this case, we need to know that this FC, okay, FC, or we can do something else. FC is basically equal to, okay, some of you might write it this way, L minus 4c square minus d over d square plus half d theta d plus d theta. What is, oh sorry, this is capital D, right? D capital D is d small d, okay? And this is the LC, and then but to find in this case C, we need to set FC equal to 0, so L minus 4c d minus d plus d theta e plus d plus equal to 0. So in this case, what we expect is, I don't know how the line look like. Let me double check if I have my solution here. Okay, so the solution is that if you plot it, it will be something like this. And when FC is equal to 0, this is the value of, this is FC, this is C. So this is the C root, which is the solution, So just replace all the values that you know in this equation, and then plot and see if you find the root. So let me, okay, so in this case, right, so write an equation of all term variable involved. Okay, so in this case, okay, so this is the equation. Okay, and this is the condition for you to find the C. So if I write it in terms of numbers, I put it, so this is something like FC must equal to, okay, my solution is the other way. So my solution is the other way. My solution is, okay, this is what I showed you, but my solution from what I did last night was this one, 4sk minus d square root plus 1 d theta capital D plus d theta d minus L equal to 0. Can this be accepted? Can this give us the solution? Anyone? Anyone? What's the difference between the first one and the second one? What's the difference? Is it the same or is it not the same? Anyone? Anyone? No, not the graph, right? Okay, let's forget about this first. Let's forget about the graph. Let's forget about the graph first. So which equation can I use? Can I use this one or can I use this one? Can both be used? What's the difference between this one and this one? Will they give the same solution? Should be. Minus setengah. Siapa yang cakap tadi tu? Can you explain yourself, please? Sorry, saya tak nampak chat. Khairil. Kenapa setengah ni? Should be 1/2. So it should be 1 or 2. Khairil? Senyap pula dia. Okay. So please say something. Okay, so Khairil kata setengah. Why is it setengah? Okay, so for you who basically confused now, which one can be used? Let's look at this basic equation. Let's look at this basic equation. The equation is simply says that L equal to 4c square minus d square plus half d theta capital D small d theta small d. Okay, so look at this. Okay, remember the equal signs. Equal sign mean the left hand side and the right hand side must be equal. So if I do this, is this correct? Is this correct? Betul tak? Is this correct?
It should be negative 1/2, Doctor, right?
Okay, negative 1/2. So this is my algebra. Okay, so right, so okay, so can I also do this? Boleh. So okay, this is my solution. So this one kita ada silap lah. So this one should be a minus. Sebab tukar tanda. Alright, so this is one way. So my solution, I'm using this. So now can you see that both of them this one, and this one are the same. Do you think they'll give you the same result? Oh, not this one. Sorry. This one, yeah. So equation 1 or equation number 2 will give you the same result. Will give you the same result. It's just a matter of sign. Just a matter of sign. But both, remember, as long as you can set it equal to 0, then you can get the solution. Okay. So in this case, I'm using my solution, and because I do not want to go over and redo my solution. So my solution is based on this one. Okay, based on this one, and the plot will look something. You might be using this as your solution. Oh, sorry, not this. You might be using this one, but I'm using this one. My solution, this one. Okay, so the plot look.
The 4c is square c, right?
Okay, yes. This is just my typo. Please look at the question paper. This is just a typo here. My typo, because oops, where is it? It should be here. Okay, so this is 4c square 4c square. So this is 4c square. Okay, and this one, of course, this one for okay, again, this is another typo. This is another typo. Please look at your question paper because I'm writing this and I'll do a lot of mistake when writing this. So d minus d square and so on. Okay. All right. So my solution is based on this one. I don't know how you do it, but this is my solution. Okay. So the plot will look something like this one. Okay. So I think when you use this equation, it will something else, but it will cross the x-axis where this is the c root. Okay, so that's the first part of the question. That's the first part of the question, which is this one. The second one is due to design constraint, the center distance can only be varied between 495 and 520 because you can only adjust this. A minimum of 495, maybe you can extend this a little bit to 520. So the question here is, due to design constraint, will the center distance meet the belt line requirement? Okay, should be this. Okay, so we know that what we need to find is to see if we can find the length of the belt if we can adjust the center distance between 495 to 520. So this is what we want to see. So in this case, what we want to do is, you see from the plot, my C root is equal about 504.4, 5.4. So my C root is 5.4.4, and the requirement is 495, right? 495 and 520. So from the plot, we know that the bed length meets the requirement. The bed length of 504, sorry, the bed length of 1727 met the design requirement. So length is 1727. So it will meet the design requirement. Okay. So in other way, what this question is asking you, if there is a root between this C, this length, because between this range. So how do we know there's a root between 495 and 520? So since you have already plotted the equation, you see that there's a root. Or if you didn't draw it, what you can see is that F495 is a positive number in my case, F520 is a negative number, and we know that the product of F495 and F520 is a negative number. So what does this tell us? This is basically telling us that there's a root between 495 and 520, as you can see from your plot. The only problem is that in the test, you might not be able to plot because you do not have time. You don't have time. So what you can do here is you can see if there's a change of sign from 495 to 520. It's a positive, 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 0, negative, negative, negative. So there's a sign change. Or you can see that 495 is positive, F520 is negative, and the product is a negative number. So you know there's a root between it. So this is the basis of your guesses. The basis of your guesses. Because the next question, I guess, okay, right. So this one is settled, but numerical method. So for the numerical method, repeat the same problem using bisection method. Okay, what are the initial two guesses? Okay, what are the initial two guesses? So in this case, the initial two guesses is 495 and 520. Why? Why is it 495 and 520? Because if you look at the slides, it says that the first thing that you need to do is the gases must produce a product of negative, because we want to have a change of sign. Okay, so these are the gases. I think some of you are smarter because you do not want to do a repetition, a lot of repetition. So you say it is between 500 and 510. You reduce it because you do not want to do a lot of loops. But doesn't matter, because if you start with these two numbers and you want to get two decimal places, your answer might be different when you use these two values as your guesses. Okay, so this is why I'm telling you that the most important part is that you must understand what you are doing. Okay, so it is not to get the exact solution as my solution and the exact root as my solution, because my solution is using 495 and 520. Some other students, because they check and they say, okay, they use something else, maybe 500 and 510. Okay, and we know that from the plot, it is about 504.4. 504.4. Okay, from the plot, it is 504.4. So some of students reduce the guesses. But if you use 495 and 520, it's still okay. Okay, still okay. But the answer here might be different. 495 and 500, 520 and 510. They will give you a different root. Okay, because this is only up to 2 decimal places. All right, so the important thing is, for up to 2 decimal places, what is the epsilon s? Okay, what is the epsilon s? This is more important when to stop the calculation. Okay, when to stop the calculation. I think I gave you this in the lecture last time. I gave you this. So now again, repeat the same problem using secant method. Okay, so this is what we call the bracketing method. Why is it called a bracket? Because it must have a lower guess and an upper guess, and the root must be in between this. In this case, C low and C upper, in between CL and CU. So it bracket the root. That is why your first two guesses, must change the sign. Must change the sign of your equation or your function. Okay, your function. All right, so let's go and do secant method. Oh, sorry, not secant method. Let's do the bisection method. Okay, please, when you do this during the test, please do not just copy paste your Excel, because again, let me repeat, this is where the mark is. Okay, this is where the mark is. The understanding of the method, not about the answer using the method. Okay, but mostly the understanding of the method. Okay, so if you look, if you remember, the first thing that you need to do is bisection method. Is a bisection method. The first thing is, I don't remember what was the first two, the first step in bisection method. Can anybody tell me? Can anybody tell me?
To find two guesses, initial guesses.
Okay, two guesses. So what are the requirements? What are the requirements? The requirement is that FCL times FCU must be a negative number, right? Must be a negative number. So if your FCL is negative and FCU is positive, so the product of this is a negative number, right? So this is acceptable, right? Or you might have this CL is a positive number and CU is a negative number, then your FCL and FCU is again negative. So this is acceptable. These two are acceptable. But if you have this kind of guesses, CU, then this is not acceptable. This is not acceptable. And the same thing here. Positive and positive, then positive. So why are these two cannot be used? Can anybody tell me why? Can anybody tell me why we cannot use these gases? Okay, let's look at the plot again. We know that our root is here, but if FCL and FCU here positive, so is there a root in between CL and CU?
No root.
No root. So that is why when there's no sign change, we cannot use that value. Okay, and this is one case. This is another case. CLO and CU. So is there a root between those two? There's no root here. There's no root here, right? So that is why we need a change in sign. This is the basic idea of how to find the root. And some of you, from my experience, from my past experience, you just put in a number and run the number. And you do not get the solution after a lot of iterations. So that is why if you look at the question paper, it is designed to help you actually. It is designed to help you. So that is why, for example, part B, it is asking you if you double check for your guesses. Okay. So if you check for your guesses, then you cannot get the solution. Okay. If the product is a positive number, then you cannot get the root. You cannot get the root. So this is the idea. So if you look at the question, this is my question last time. So my question is always designed to steer, to direct students to the right procedure. Okay, but you need to do it step by step. So part A, part B, part C are all the steps. Are all the steps to getting the right direction. of solving the problem. Okay, this is what we call guided question. This is guided question. So please do not ignore any parts, because if you ignore, you might miss a step. So this is my question. I think, again, it's the same thing for the other lecturers because I'm the coordinator. I always ask the other lecturers to design a question in such a way that it will help you understand it and get the solution. Understand the problem and get the solution. All right, so that's the first step. Determining the gases. What's number two? What's number two? Okay, two gases, and the requirement are this. It must be a negative number. So this is not accepted, but this is okay. So what's the second one? What's the second one? The second one is basically trying to find the root. And we say that we Cl plus Cu over 2. So what we are trying to do here, let's say our first requirement is that we already have a sign change. So this is our root. And then this is our C-axis. Okay, this is our Fc. Okay, so let's say this is our gas, gases, Cu and C upper, and then Cr is just half of the product, half of the sum, which is the average. So this is our Cr, our Cr, okay, our Cr. So how about that? And what we do is to check where is the root. Is it in the lower subinterval or the upper subinterval? So lower interval is from Cl to Cr, and upper interval is from Cr to Cu. So what we do here is we find that C lower. So in this case, C lower is positive, and Cr is also positive. So we say, because in this case, FCl and FCr is a positive number, what we can say is that no root in the lower subinterval. So root is in the upper interval. Is that correct? Is that correct? Because there's no root here, and of course it must be on this side here, which is the upper subinterval. So now what we need to do is we need to change this. So we need to change this to our new Cl. Okay, our new. The Cu remain the same, but our Cl now changes. So we say set Cl equal to Cr, new Cl. Set new Cl equal Cr. Now look at this. FCl. Now this one is Cl. FCl times you need to do again, repeat the thing, repeat the thing, which is now Cr. Our new Cr is now this. Okay. So our new Cl now, our new root, our new Cr now is Cl Cu over 2, which is repeating the same thing here. Repeating the same thing. So now our Cr is somewhere here. Let's say our new Cr is there. And we note that now FCl, the new FCl times FCr is a negative number. And what we say is that now we say that our root is in lower subinterval. Lower subinterval, which is, if you look at this, let me change this to something else. Be black now. Now we know that the root is somewhere. Yeah. So we know that now our next iteration, our CU is this one. Our CU is this one. Now this is the new interval that we need to investigate. Okay. So now the next thing is that set a new CU equal to C R. So can you see that if we repeat this multiple times, then we see that the interval becomes smaller, 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 and smaller, and at the end, it will basically overlap the root. This is the idea behind. This is the idea behind bisection method. This is the idea behind bisection method. So let me write my solution here. Let me write my solution. So basically what I have here is my guesses. My initial guesses is CL. My initial guesses CL is 495, just like CU is 520. And we know that in this case FCL times FCU is a negative number because there's a root. So I think you can see that from the plot. From the plot, we know that there's already a root here. Okay, so what we need to do now is to find our first iteration. CR equal to 495 plus 520 over 2, which is now 507.5. And then we need to find what is FCR. FCR is a negative number. Okay, and then we need to see FCL times FCR. Okay, and FAL times FCR is a negative number. So what we can say is root is in the lower subinterval. Okay, which is between what we can say is C root is between 495 and 507.5. Okay, so now set CU now 507. Set new CU. Because our root is between this range. And now what we do is again repeat. We know already FCL. No, sorry, this is now FCR, new FCR. Okay, let me change color. Okay, this one is now second iteration. FCL. Okay, sorry, FCR. Let's just do this now. 507.5 is a negative number. Sorry, not. Okay, it's a negative number. Okay, and then our 495.5 is positive. Let me see. Okay, it's a positive number. 495.495, and not 495.5, sorry. That's why I got confused here. 495 is the positive number. Okay, so negative, eh? So F 495 plus times 457.5 is a negative. So what we can see here is that root is in the lower. Okay, this is what I want to see. This is what I want to see. I want you to see that, okay, how do you know where is the root? Is it in the upper interval, sub-interval, or in the lower sub-interval? This is what I want to see. Okay, so now, then we can see if you continue, I get, I think the last interval, I'm not sure if I get this right, because it says that, I think my root is 505 something, 505 something. But now, the question here is asking you about 2 decimal places. 2 decimal places. So how do you know when to stop? How do you know when to stop? Okay, of course, we need to do error analysis. We need to do error analysis here. So how do we find the error? How do we do the error analysis here? How do you do the error analysis? Okay, so we know that our root was, before this was 507. We need to see, maybe in this case, what we get here is, I get 505.9375. And the other iteration, I get 505.156. Oh, sorry, not that one. Not that one. Sorry. So let me see. This is my. Let me list down my iteration. So what I get here is my root. My root is 507.5. The first iteration. The second iteration is 501.25. The next one is, okay, so what's the error here? What's the error between this? What's the error between this? The question asks for your root to be up to decimal places. Value up to 2 decimal places. So you can see here, this is 507, this is 501. This is very far. This is not even close. So the answer here is, okay, so 5, and then what we get is 504.375. Oh, sorry, 504.375 and 505.1563. So this is not even close. This is 507, 501, 504, 505. This is 505.9375. If 505.156 4275. Okay, this is wrong. This is wrong. It shouldn't be there here. I miss a skip. I skip. Okay. So okay, now when it comes to here, this is already. We see that our round number is already the same. So now we can see that. I have a problem here. Okay, and then the next one is 505, 504, 176. Sorry, 504. See, this is not even close. 504.57, 504.5703, 7656. 5703 4727. Okay, so this is not really a good example, yeah, because what you want to see is you need to stabilize until 2 decimal places. So, but this is not even close to 2 decimal places. So, the error to stop here is that ES must equal to 0.005, because this is the last number that you need to round up or round down because of this. Okay, so you need to see this one. So maybe this is not a good question, because finally what I get is 504.49. Then between 504 point. Oh no, this is 454971. 5215. So this is still far away. So this is not a good question. Okay, this is not a good question. Maybe I'll give another one before the test. I'll give another one before the test so that we can redo this in such a way. Maybe I can give you another one. So this is not a good example, because this is good for exercise and not for test. Because test you're short of time. You are short of time. All right. So this final solution is, what I get is 504.4971, and the other one is 54849. So if you look at this, okay, because this is already this is 4849. This is 4849. This is should have another, because this should be for example. This is already 50, right? If you round it up, so the answer should be around this number, 504 point. If you are into 1 decimal places, okay, 1 decimal places is 0.05. So this is good, So either 0.49 or 504.5, because this is already 504.5. This is the same thing, 504.5. So if you are only to 1 decimal place, this is a good answer. This is a good answer. Okay, I'm sorry, because I think I overlooked this question, and this is not good for your test. It's good for exercise, but this is it's a long iteration. I believe my iteration, even for 1 decimal place, is already 10 iterations. So this is not a good question. I'm sorry about that. Okay, so the next thing is about secant method. I think the next one is about secant method. Okay, repeat using bisection, and then repeat the same problem using secant method. So secant method falls under what we call an open method. So what is an open method here? How many guesses do we need? How many guesses do we need? How many guesses do we need here? How many guesses? Is it 2 or is it 1? Okay, so for open method, we have 2 categories. One is Newton-Raphson, and the other one is secant. So C-A-N-T. Secant method. So what's the difference between Newton-Raphson and secant method? Can anyone tell me what's the difference? Anyone? Can you even take a look at the textbook? What's the difference? What's the difference? Anyway, is anybody there? Is anybody watching the video or watching my live session now? Hello? Say something, please. Okay, in that case, why don't you take a look yourself? I don't want to tell you, I don't want to spoon feed everything to you. So please read the textbook. Hopefully you know the difference between secant method and meter absent method. Yeah. All right. So I'm using secant method, and secant method is requires that, for example, for secant method, let's say this is my line again. This is my line. So what we need to do is we only need one guess. Okay, we only need one guess. So this is the one. Let's say I'm using this as a guess. So this is my first guess. But what's the issue here? What's the issue here? So how do we find macam bracketing method? We need two guesses because it will bracket the solution, right? The root in between lower and upper, the lower and upper values. Okay. So now in this open method, we only need one guess. So the idea here is that we guess, and using the slope at that point, we get a new point, and from that new point, we evaluate the slope again until it will overlap the root. It will overlap the root. Okay, that's the idea. But okay, sometimes to find the slope, this is not easy. It is not easy to find the slope. Sometimes it's not easy. So to find the slope, sometimes it is not easy. It's not easy to find the slope because, for example, your equation. How do you find the slope for the equation? Let's see. What's the slope for this equation here? What's the slope for this equation? Oh, sorry. What's the slope for not this one? What's the slope for this equation? Can anybody tell me how do we find the slope? If you have a function, how do we find the slope? Okay. Maybe let me rephrase you to a simpler question. So if I have y equal to x squared, so the slope of the line. Okay, how do I find the slope? What is the slope of, let's say, fx? What's the slope of fx? Can anybody tell me?
X squared.
What's that?
X squared.
Kuat sikit, tak dengar. Siapa ni? Alif Daniel Alif. Kuat sikit.
The slope is the x squared.
X square.
Yes, is it?
Kuatlah sikit, saya tak dengar. Sebab kat sini tengah buat construction, bising. Memang tengah repair bilik air. So, what's this?
Yeah, square is the slope for the equation.
X square is the slope.
Is it?
Okay, so by definition, in mathematical terms, by definition, if you have a function fx equal to x squared, so the slope is just the differentiation of the function x, which is 2x. That's the slope. That's the slope. For example, okay, so x squared looks something like this. Okay, this is x squared. So let's say the slope at x equal to 1. At x equal to 1, the slope is this slope. So it's a straight line, right? It's a straight line. So that's why you look at this. This is a straight line. Okay, so in this case, slope at x equal to 1 is just 2 times 1, which is 2. Okay, so this is how you find the slope. But unfortunately, sometimes for this open method, the slope is not easy to find. For example, if you look at this equation, okay, take a note that theta capital D and theta small d, okay, we have, I don't remember this one, This one is, I don't remember the equation, but if you try to differentiate this equation, there's another term here that you must be very careful with. Okay, so this is not easy to find the slope. Okay, so that's the one of the disadvantages using open method, because it needs the slope. And sometimes the slope of that equation that you are trying to solve is not easy to find. It's not easy to find. Okay, this is the issue here. This is the issue. Okay, x squared is not the. This is the function. This is the function, and the slope of the function is this. Okay, slope of the function. Okay, the slope of this function is just the differentiation with respect to x, with respect to the dependent variable of the function. Okay, this is basic mathematics. Basic mathematics. This is basic calculus. Basic calculus. So the idea here is that you know that the mu c is just equal to this case, the mu c is just I don't have a solution with me here. Okay, if you take a look at my video, I mentioned how to find the mu c. Okay, so from my Excel sheet, what I get here is after 2 iterations, I already get the solution, which is 504.27. Sorry, after 1 iteration. After 1 iteration. So this is the solution up to 2 decimal places, because the next cycle, the next iteration, what I get is 504.27. This is 270, this is 271. So this is good to up to 2 decimal places. Up to 2 decimal places. So only 2 iterations. Only 2 iterations, I get the solutions. I get the solution. Okay. So this is the advantage. If I use bisection method, it will take me even up to 10 iteration. It's only 504.48. Okay, 0.48. So it's a long way to go. It's a long way to go. It's a long way to go. So the exact solution is 504.271.7945. This is the exact solution. All right, so you need to watch my video. You need to watch my video about this. Okay, so this is the solution for using secant method. So the next question is asking you about comment on the methods, level of difficulty. How difficult is it? Which one is more difficult, bisection method or secant method? Okay, it depends. It depends. Sometimes looking at the solution, looking at the equation, the function, sometimes the function, if the function is linear, then you have no issue because it is easy to differentiate and you can use secant method. Okay, so it depends. Okay, if the function is not easy to differentiate, then bisection method is easier. Okay, how about convergence rate? How about convergence rate? Which one is quick to give you the solution? So if you look at my solution, even after 10 iteration, my answer has not converged to the to the exact root. Okay, using bisection method. So convergence rate of bisection method is slower compared to secant method, because my secant method, it took me only 2 iterations, in this case 3 iterations to get the true solution. Okay, accuracy is depends. Again, accuracy is hopefully the same, but one method, which is bisection method, requires more iteration compared to compared to secant method. Okay, compared to secant method. So this is the my comment. This is my comment. Okay, so any questions so far on this one? Any comment? Any comment? Any comment? Any comment? Okay, if there's no comment, can you give me 5 minutes? I need to make an important phone call before we go to talking about assignment 5, which is the test question. All right, so let's take a break for 5 minutes. Be back here at 9:45. At 9:45. Okay. Okay, let's start. Let's start again. Hopefully everyone is back here. So let me talk about assignment number 5 here. Assignment number 5. So assignment number 5 is just your test 1 review. Just your test 1 review. I don't remember. I think this is from last semester, our previous semester. That's the one before this. The one before this. Okay, so let's look at this question. So again, I want to remind you that the test question always contains 3 parts. The first part is always about the understanding part. Okay, or when you understand it, you can do the derivation of the governing equation. Okay, that's the first one. The second thing is that the method that you use to solve the governing equation, the numerical method that you use to solve the governing equation. That's the second one. The third one is the error analysis. The error analysis. Okay, so is everyone here? Hello? Hello?
Yes, Doctor.
All right, good. Okay, at least 1 or 2 is here. Okay, so this is the idea behind every test question. Okay, every test question. Question 1, question 2, question 3. There's always 3 parts. First is the understanding part or the derivation of the governing equation. The second part is the method, the numerical method that you use to solve the governing equation. The third one is always asking you about the error analysis. When you have error analysis, normally you have the analytical solution. Normally you have the analytical solution. Okay, the analytical solution, either you get it from your part 1, which is the understanding, or the derivation of the governing equation. Okay, so this is the overview of every question in the test. So be prepared. Be prepared. Again, the test question is cognitive level 3 or level 4. Level 3 or level 4. So if you just remember the steps of using bisection method, for example, or the step of doing secant method, for example, without understanding, then you cannot solve the solution. You cannot find the solution. You cannot solve the problem. So this is the idea behind the test. Please do not just memorize the steps. Do not do that. You cannot answer the question. This is cognitive level 3 minimum. Cognitive level 3 or level 4. Okay. All right. So the past in this question, question number 1 is asking you, for example, part 1 is about the understanding part. Okay. So please answer briefly yes, true or false, and give your reasons. Okay, true or false, and give your reason why. Jangan answer true or false saja. Please answer true because, false because. Okay, so that is what we wanted here. Okay, so part B here, part 1, B, explain convergence and divergence in case of Newton-Raphson method. Okay, so this is the part B, and part C, again, you need to understand this to answer the question. Again, please understand. Do not just memorize because it will not work. Memorize is the lowest level of understanding, which is C1. Okay, which is C1. We are at C3 minimum. We are at C3. Okay, so this is the question. Part 2, asking about this one here is the problem. And the solution is already given here. Okay, it's already given. This is similar to the open belt length or open belt system. Okay, and now look at this. Develop a new modeling equation in such a way in the form of this, which means you need to know how to set it equal to 0. Okay, so this is the understanding part. The first thing is set it equal to 0, and then find whatever it wants in this case. Friction factor, determine the friction factor, which is the friction factor in this case. I think F is Darcy friction factor. So you need to find F here. You need to find F. So look at this. F is here and F is here. And note that this is 1 over square root of F. And this is not easy to. Not only that, it is part of log. So basically what we can say, F is our implicit variable. So it's not easy to solve. It's not easy to solve. Okay. So you need to use the numerical method. So use an appropriate method to determine F using modeling equation developed in part A. Compute the calculation. Okay, and this is the given that Moody chart, the Darcy friction factor is within the range of this. So this is just like my open belt system, asking you basically, is there a root between these two ranges? Okay, if there is a root, then continue with these two gases. Okay, so this is the true value. True value of friction factor is this. So you need to find result B. Basically, you need to know the error. Okay, and take a look at this equation, this question. It says, in this case, it says only 3 iterations. Only 3 iterations. Okay, 3 iterations, enough. 3 iterations. So you do not need Excel in this case. It's only 3 iterations, right? So simple and quick. Okay, so you need to compare. So in this case, part B, if you look at this, part B is basically, sorry, part C is your error analysis. Is your error analysis. Okay, how good is your solution? Remember that we have accuracy and we have precision. So the precision is always about the error. So now determine P for this. So basically, once you know what is your friction factor, you can use your P, which is this. F is already known, right? So can you find what is P? Okay, L is already given. L is the length. Okay, so this is the question. So this is very straightforward. Straightforward question if you understand what you need to do. Okay, the problem is you don't understand this, and that is when your solution is incorrect. Right, so that's part 1, question 1. This is question number 2. Wow, I think this is similar to our assignment, right? This is similar to our assignment 3, if I'm not mistaken, or assignment 4. I don't remember. Assignment 3. Very similar. So from this, you need to set up. It says here, write down all the steady state mass balance equation for each room, which means in this case we have 1, 2, 3 rooms. Then we'll have 3 equations, right? Or is it 3 or 4? So in this case, I think there's one more. There's one more because 1, 2, 3. This one. Here the partition is me. That's number 3. That's number 4. So there are 4 rooms basically. These are the buildings. So there are 4 sections here of 4 rooms. Then we know there will be 4 equations that can become a 4 by 4 matrix. In this case, augmented matrix, because it's adding up the coefficient, not the value. So you need to prove. Okay, you need to make sure that this part here, your equation, can be converted into this. Okay, if you can do that, and is it the same as this one, then you are okay. You know that your equations are all correct. But just in case you didn't get the right matrix here, you can skip part A. You can go straight away to part B. Okay, so it will help. Basically, if you are stuck at part A, don't wait too long. Okay, continue with part B, because part B, it is the matrix is already given. The matrix is already given. And part C, it says here, explain the difference between Gauss elimination and Gauss-Jordan elimination method. Okay, so in this case, you need to understand what is Gauss elimination and what is Gauss-Jordan elimination in order to explain the differences. Okay, if not, if you just memorize the steps, I don't think you can explain this. Okay, hence choose one method which requires making the matrix upper triangular and solve the problem given in part B. And it says here, please note that you need to show and explain all details involved in the calculation. Okay, if there's no details, then most of the marks are here. All the marks are here. Okay, now this is the what if situation. If the diffusive mixing between room 3 is eliminated, rewrite the steady state mass balance equation for room number 1. Okay, yang ni, this one you need to understand. So basically, room 1 and room 3 is eliminated. It says that mixing between room 1 and 3 and is eliminated. What is the what does the concentration in room 1 will change in such state, in such case? Okay, so you need to find what is C. I think C. Where is the room 1? This one is C. Diffusivity is what is diffusivity here? Is it Q? This is mass flow or airflow. I think C. C is diffusivity. Okay, so I think part C. What are the unknowns here? Okay, I don't have the solution for this at this moment, but I'm telling you, this is the kind of question you can expect in test. So this is what if. This is what if situation, and this one is also what if. And again, you need to understand what is Gauss-Seidel method in order to answer part E. Okay, it says that justify your answer. Basically, give the reason. Give reason why converge or not converging. Why? Okay, question number 3 is your assignment number 4, which is your eigenvector problem. So the trick here for you is to draw the free body diagram. Okay, once you get the free body diagram, you need to do the summation of forces must equal to M A. Okay, for in this case there are 2 masses. Okay, for both masses, which is for both masses. But note that this is tricky because we have one K connected to mass number 1, another K connecting between M1 and M2, and then one K connecting only to M2. Okay, we have a free body diagram, so you need to draw your free body diagram. Prove that equation of motion for both masses in matrix form, in this case, starting from summation of forces equal to MA, can be expressed as this. Okay, normally, if you have 2 masses, there'll be 2 equations. Okay, mass 1, equation for mass 1, and equation for mass 2. Okay, equation for mass 1 and equation for mass 2. Okay, so this is one of the ways to see how the matrix. So in this case, the matrix is a 2 by 2 matrix because we have 2 masses. Right, so in this case, just in case you cannot do, again, part A, the equation has already been given here. So part B, solve for this matrix. Solve using this matrix, find what is the eigenvector. What is the eigenvector? Up to 4 iterations. Remember here, 4 iterations. Okay, corresponding eigenvectors up to 4. Sorry, find the largest eigenvalue and its corresponding eigenvectors up to 4 iterations. So this is the same one as your assignment, the same one, because I think the question is just copy paste here, but the situation is different, the figure is different. Okay, starting from equation 3.1, determine the characteristic equation. Okay, if you watch my video, you should understand what is characteristic equation. And then determine all eigenvalues using based on part C, using the parameter mentioned in part B. So basically what you can do here, part D, it says that determine all eigenvalues, which means you need to solve this not using numerical method, but using analytical methods. Okay, because part C is basically characteristic equation. So you get the characteristic equation, you can solve for the eigenvalue using this characteristic equation. Again, this is in my video. You should watch my video. Okay, compare the answer in part B and that of part D, this one and this one. And it says that, so this one B is numerical method, D is analytical method, and compare B and D. Can the initial gases be other than A naught? Can it be other than this one? Can it be other than A naught? Okay, can it be 1 and 10, for example? Can it be 2 and 5? Okay. Please explain your answer. Please explain your answer. So again, this is the what is to be expected in your test 1. What is to be expected in test 1. Okay, so I think we should stop now. It's already 10 o'clock. Okay, so I think thank you very much everyone for joining, and we see you again next class on Thursday. All right, everyone, thank you very much.